Ever wondered about the intricate workings of a charging circuit? How does this essential component of our everyday devices function? Let's unravel this mystery together. The charging circuit is a complex entity composed of several key components, each serving a unique function. The charging IC, or U401, takes on the task of producing the charging voltage and keeping a check on the battery percentage. It oversees the entire charging process, interacting closely with the CPU. Then we have the USB IC, or U1700, which ensures the charging voltage doesn't exceed the safe limit. It also acts as the wake-up call for other components involved in the charging process. The CPU, or U201, serves as the master controller, overseeing the entire charging process. Charging MOSFET, or Q1403, is the guardian, ensuring the current distribution is even and protecting against overvoltage or overcurrent situations. The battery connector, J523, and dock connector provide the crucial links between the battery, motherboard, charging cable, and logic board. As the phone is plugged in, the charging voltage is outputted to the charging IC and Q1701 via J117. This voltage is then sent to the USB IC for voltage detection. If the detected charging voltage falls within a safe range, the USB IC sends a host machine reset signal to the PMU. This signal activates the modules related to the charging process. Simultaneously, the USB IC sends an enable signal to the charging IC, confirming that the charging voltage is safe. Next, the charging IC sends a charging interrupt signal to the PMU. This signal alerts the PMU of a pending charging task. The PMU, in turn, informs the CPU. The CPU then controls the charging IC via the I2C bus. The charging IC transmits information such as battery percentage and battery data to the CPU. Once the CPU verifies the battery information and charging voltage, it informs the charging IC to proceed with the charging task. The charging IC, forming a buck circuit with L401 and SIN402, converts the charging voltage into the main power supply voltage. A portion of this main power supply voltage is fed back into the charging IC, which then generates the battery charging voltage. This voltage is transmitted to the battery, charging it. The remaining main power supply voltage is transmitted to Q4403. Upon receiving the charging activating signal from the charging IC, Q403 completes its breaker, transmitting the main power supply voltage to the battery connector and charges the battery. Throughout the charging process, the PMU and charging IC monitor the battery charging voltage. The charging IC adjusts the current of two voltage rails based on the battery's current voltage, percentage, and temperature. This adjustment ensures that the battery charging process is safe and smooth. In summary, the charging circuit is a marvel of engineering, each component working in harmony to ensure our devices stay powered. From voltage detection to charging task verification, and ultimately battery charging, the charging circuit is an unsung hero in our daily lives.